Okay, good morning all. So today we'll see next theorems from Boolean algebra. Consensus theorem. And the theorem is AB plus A complement C plus equal to AB plus A complement C. Okay, so I'll give you 2 minutes. Just try to solve this expression with the logic of your normal algebra, whatever you learned this Boolean algebra. So for that reason, to solve this, whatever is long term or the term any side which is linked to take that term to solve, right? And given example, I think LHS is a lengthy term, so that you need to take for solution, right? So this is a term. Okay. Now start solving this just by just use whatever that you learned earlier. I'll give you 2 minutes. Just try to solve this. Just try to solve this. Okay. Anyone has any to solve this expression? Put it in chat. Anyone has any clue? Check what is common, how actually the things are there in that relation, what things keep as common, how is denoted. Keep on that perspective, how treating the things on what operator, that also you can check. Okay, let it be. I'll give you the explanation. Keep an eyes on the expression which is written on C. Two things are there, two variables are there, B, and one variable A is common in that expression. And your third term actually made up of the variables which are there in first and second term. In such cases, you need to solve this expression by adding term, right? If you find that the term which is there in that expression is made up of terms which are there or variables which are there in other terms, in that case you need to check. When you need to check? When a variable is common in those terms, right? In that case, you are possibly unable to solve such kind of expression. In that case, you need to add the term which is common, right? You need to add the variable, or you can say you need to add the variable where the term is common into that expression. How to add? Now keep in mind that there are two types of terms. One is product term. What actually that product term and all we'll see in further lectures. Just time being, keep in mind that there are two types of terms, product term and sum term. Product term, that means a variable, right? Variables are separated with and gate, and sum term, in that case, sum term means the variables are separated with or gate, right? In product term, it is with and gate. Now, what you need to add, if that expressions has product term, then you need to add sum term, right? If in that expression product terms are there, you need to add some term of missing expression, or you can say missing variable. Which one is missing variable here in that term? In third term, which one is missing variable? Yes, exactly. A is missing variable. In that case, AB plus A complement C plus BC into A plus A complement, right? What is A plus A complement? Yes, what is the value of A plus A complement? Yes, obviously 1, right? So if you multiply 1 to any term, त्याची value change होते का? If we multiply 1 to any term, does the value of that term changes? Obviously, yes. No. So you need to solve this. AB plus A complement C plus A B C plus A complement BC, right? You multiply A with BC and A complement with, right? So this is how we multiply the things. Now what is common? You have to find is this term, and this term has something common in it. Again, this term and this term has something common in it, right? So we need to find out that common. What is common in this is AB. If we put AB as common, we'll get 1 plus C there, plus in this term A complement C is common, again we get 1 plus C. right? If you odd anything with 1, that means 1, right? Plus A complement C, 1. If you multiply 1 with that term, means that term only. AB plus A complement, right? So this is how, and actually this is your RHS, right? This is how the expression becomes solved, right? This consensus theorem is also referred as included factor theorem, right? Why? Because we include something here in that expression, right? So this consensus theorem is also referred as included factor theorem, right? So you can have, see, we are talking just about three variables, right? Only three variables are there in that expression. Those variables are A, B, and C. You can have this kind of expression for any number of variables. You can add number of variable in that factor also, but you need to check only whether the what actually the term is missing, and the terms which are made up of different variables which are there in expressions, right? That you need to check. So this is about first theorem. Then theorem second is A plus B, A complement plus C, then B plus C equal to A plus B, A complement plus. Okay, try to solve this. Try to solve this. What you need to do here is you need to take LHS for solving. In that case, just multiply the things what all there, and then if you are multiplying the things from LHS, then you need to take RHS as well, right, to solve. And you need to check whether both LHS and RHS are same in this case, right? So first and foremost thing here is we need to check for first two terms. Am I audible, right? Are you with me? Am I audible? Okay. Okay. So what we need to do is A with A complement and C, and B with A complement and C, right? So A complement plus A C plus A complement B plus B C, right? So this is how we B plus C, the term which is keep as it is. A and A complement is 0. So what remains is AC plus A complement B plus BC and B plus C. Now what you need to do is, in this case, hmm, multiply B with all terms, and again multiply C with all terms, right? So A, B, C plus A complement B, right? Plus A complement B plus B, rather A complement B, B. Then you may say B complement, sorry, B, B, C plus A, C, A, C to C plus A complement B, C, then B, C dot C. Then B dot B is same B, again B dot B is same B, C dot C is C, C dot C is C. Then A, B, C equal to A complement, sorry, plus A complement B plus BC plus AC plus A complement BC plus BC. Now what is common here is BC, A plus A complement BC, then A complement B plus BC plus AC plus BC. Right? So many things are common here. This is one, right? So this BC is common, right? Three BCs are common. Then A complement. So what is there at the end is this AC, then A complement B and BC. This is your answer for LHS. Now you need to check for RHS. Try to solve this. Try to solve RHS. Hmm. What you need to do in RHS is A into A complement B into C, and then B into A complement and B into, right. So you need to find this there and okay. Try to solve this. We'll go for next theorem, and that is called so theorem is AB plus A complement C equal to A plus C and A complement. Okay. Put RHS equal for solving plus C and A complement plus B. Try to solve this. You will get LHS, right? Try to solve this. You will get LHS. A complement plus A C plus A complement C plus B C, right? A complement is 0. So A B plus A complement C plus B C, right? Here it comes as consensus theorem, right? B, one variable is common, and third term is made up of variables which are there in first and second, right? So you need to include a plus a complement here. Then you will get the answer, right? And that answer is just like whatever there in LXS of this theorem. So try to solve this. AB plus A complement C plus ABC plus A complement BC, right? So what is common there? AB is common in those terms, right? We'll put AB as common there, then 1 plus C plus C, right? Sorry. AB is right. AB is common in this term, and EC is common in this term, right? So 1 plus C here plus AC common, right? AC common, okay? 1 plus, right? So 1 plus anything is 1. 1 plus anything is 1. So AB plus A complement C, right? Which is equal to LHS. So this is about transposition theorem. Are you with me? Are you with me? Getting the things what is going on. समजते का तुम्हाला जे काही चाललंय? समजतंय का? ओके. याच्या अजून क्लिअर आयडिया होतील जसं आपण पुढे जाईल. टाइम बिंग फक्त हे रूल्स अप्लाय करायचं चेक करा फक्त जे चाललंय. Yeah, actually checking about what all theorems are there, right? So this is about De Morgan's theorem. Now next is sorry, this is about transposition theorem. Now next is De Morgan. I think De Morgan झालाय का तुम्हाला? De Morgan's theorem ऐकलंय का? De Morgan's theorem. ओके. 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 तो काहीच इश्यू नाहीये. डी मॉर्गनचे कुठले कुठले थिअरम आहेत? कुठले थिअरम आहेत डी मॉर्गनचे? टेल मी लॉज, फर्स्ट लॉ and second law. Put it in chat, no? कुठले कुठले लॉज आहेत? See, De Morgan's law, first law states that if we have a variable or if we have two variables, we have sum of that and the whole complement or two variables are odd with whole complement, then that is equal to splitting of the things and changing sign from or to and, right? That means this complement or overbar is split into two parts and change of or gate into and gate, right? So try to solve this using truth table. Just find out the values for truth table, then you get to know A, B. Just find out A plus B and complement this column, right? 0 0 0 1 1 0 1 1 is combination, and try out again for A complement and B complement. Find out A complement, A B complement, and then multiplication of A and B. So this column and this column should be same in your truth table. Just find it out. I'll give you 2 minutes. Just find it out. Okay. Things are those who don't understand things are there on board. Just check. Okay. So this is how you give the proof for De Morgan's law, right? So what the law states that the complement of sum of variables, the complement of sum of variable is equal to product of their individual complement, right? Product of their individual complement. So you can extend this up to any variables. That case also. So next is law 2. A B complement equal to A complement plus B complement. The reverse thing, right? So if you check the first law proof, you will also understand the proof for second law, right? So what this law states that the law states that the complement of product of two variable, complement of product of two variable is equal to is equal to sum of their individual components, right? Is equal to sum of their individual complements, right? So this is about De Morgan's theorem. Then, then 13th theorem is Shannon's expansion theorem. That you need to check, if you have expression, you decompose it with two parts. One is positive and another is negative. Or one is if you consider A is variable, then you can um, decompose that into two parts. One contains A only, another contains A complement in that expression, right? So this is how you actually decompose. So De Morgan theorems are used in this expansions as well, right? So you can use few rules over there. So you get the question is like demorganize the expression whole complement. Okay. So try to solve this. Try to solve this. How to solve this is first split on whole bar. So A the complement into, right? This or is converted into and while splitting the complement. Then again A complement and then this plus again is converted to dot, right? Or to and A complement, AB complement, right? So if we have double complement, then the value is that itself, right? That means AB itself. AB dot A dot AB complement, right? So A into A is A itself, right? So you say that AB dot AB complement. If you have a term and their complement as a product in a single expression, then the value for that expression is treated to be 0. Why is it so? If one is true, then its complement is false. If value is false, then its complement is true. So at that moment, the value for that expression for that term is 0. If you get the term and complement in that single term only, then its value is. So this is how you are same organizing the things, right? Next is duality. This term is also there in the expression. So what actually duality is? See, we have two logics. One is positive and another one is negative logic, right? If you understand the basics, no, you get to know that there are two logics. One is positive and another one is negative, right? So if suppose zero, we consider it as in positive logic. In negative, it is treated to be as 1. If we have AND gate in positive logic, then it is treated to be as OR gate in negative logic and vice versa, right? That means things are opposite again in this case, right? If it is considered to be 1 in positive logic, it is negative 0, right? So this is, there in duality. So if you change change the logic, no, you need to change the value as well, right? If it is 0 there, then you need to put 1 in negative logic, and also you need to check on gate, right? If it is AND gate, then you need to change it to OR. That means if suppose zero's complement is there, then it is treated to be as 1, right? And what is a dual for this is one's complement equal to 0. Or if suppose A dot 0 is treated to be as 0. Why? Because anything with 0 is 0 itself. How its dual holds is change it into and to or 0 to 1, right? And to or 0 to 1, right? So those two terms are equal, right? In case of duality, right? If suppose A into A complement is 0, its dual is A plus A complement equal to 1, right? So this is how you are going to write a duality. So those dual expressions are there inside your book. The excellent book for this topic, or you may say for Boolean algebra, is Anand Kumar, Fundamental of Digital Circuit. So all those points are included there in that book, right? This is how uh, finding out dual expression for given expression, right? Now, next is the point where which is given in your syllabus, and this is the point which is mentioned in this syllabus is called reducing Boolean expression, right? Why to reduce Boolean expression? Hmm? Why to reduce expression? I think बोललो है याच्यावर आपण. Yes, exactly. To simplify circuit. So yes, anything you are writing with Boolean expression is your logic. So that logic you are going to realize. Right? Realize म्हणजे काय तर त्याचं तुम्ही सर्किट वगैरे करता. So in that, while realization, you are trying to reduce that expression, right? Why? For minimum hardware, right? Why to reduce the thing in Boolean expression is to minimize hardware, right? So to realize things in digital circuits, Boolean expressions are reduced to minimize hardware. Again, there are so many things available with reducing expression. So to minimize, there are lot many benefits to minimize hardware that we'll check on net and book as well, right? But what does the motive behind reducing Boolean expression is, as and when we are trying to realize the things, no, if it is in its reduced form, then will give will realize that expression in minimum hardware, right? So keep it that in mind. There are certain rules available with this while reducing the expression. So I'll give you those rules. Just write down or note down on your book. First rule for this is obviously, which is common in all algebra, multiply multiply all the things, or you can say all variables necessary to remove parentheses. This is your first rule, right? Multiply all variable necessary to remove parentheses. This is your first rule while reducing Boolean expression. We are using those rules to reduce the expression, right? So multiply all things. Then next is look for identical terms. So you need to find identical term. Look for identical terms. What are identical terms are there in expression, and keep only one term, right? Keep keep only one term. That means if you have in expression a plus b plus a plus b again a plus b again a plus b, right? Kind of, you need to only keep ab there, right? For all those terms, right? So find out identical terms and keep only one term in the expression. All others should be dropped. All others should be dropped. So look for identical term, only one term from those terms to be retained, and all other terms are dropped. This is your second, sorry, second uh, rule. Then third rule for this is look for a variable and its negation in same term. Look for a variable and its negation in same term, and that term could be dropped, right? Look for its variable and complement in same term, or you may say that A, B, C complement. This is also dropped. A, B, C, D complement. This is also dropped, right? So that term should be dropped, right? Then fourth rule is look for a pair of terms that are identical except one term, right? Look for the term that are identical. That means uh, ABC complement and ABC complement D complement. right? So look for the term which are identical. Look for the pair of terms which are identical except one variable, except one variable, that missing variable in one term. So if that variable is missing in another, then the larger term should be dropped, right? That means what is result? A, B, C complement, right? So this is the fifth result, fourth rule. Then fifth rule is look for pair inside this, like suppose I have A, B, C complement D, and A, B, C complement D complement is there. Then what is dropped? The variable which is common, or the variable which is there in one term and in another term its complement is present, that variable should be dropped and remaining is there in that term, right? So ABC is there. So the variable with is present with that value and its complement in those terms, that variable should be dropped in this case, right? So common is ABC there, which should be treated as in that term. So those are few rules available in reducing expressions. Okay, I'll give you reduce the expression, reduce the expression f equal to a plus b to a plus plus c complement e. Okay, so try to reduce this expression. Try to reduce this expression. So first and foremost thing is multiply whatever you get there and remove all parentheses. So we start with this and then we'll go for this, right? So first is A plus B, put all the things as it is till this. Now multiply this with, okay, multiply with D, then C complement D, right? Now again remove this parenthesis as well. A plus A B C plus B B C plus B C complement D. Right? So that could be the things, right? So A plus A B C plus B into B is B itself, B D plus B C complement. Right? Now find out what is common there. A is common in this term and BD is common in this term. Right? So find out common and put that common right, and 1 plus BC plus BD, 1 plus the complement. So 1 plus anything is 1 itself, right? So 1 into A is A plus this whole term becomes 1, this whole term becomes 1, right? B, B. Now 1 into A is A, 1 B into 1 is A. So this is how you reduce the thing. So how many gates we required here is 1, 2, 3, 4, then complement 5, then multiplication. There are so many gates we required for this expression, right? So whatever output we get from this expression, the same output will get from this expression, right? And here how many gates are required? One AND gate and one OR gate, right? So this is how we reduce the hardware. So the result of this is equal to result of this. So for that reason, we are actually using reduction method. We are reducing Boolean expression. So this is how the thing works for Boolean expression, right? So this is the result or reduced form of this expression. Till now, anyone has any issue related to today's topic? I stop sharing and recording here.